Hello, we're going to look at determinants here. And first we're going to look at 2 by 2s and then 3 by 3s and then a way of solving equations with them. First thing to notice is you always have to have a square form of this. Let's see, let's make sure I'm on the right color I want. I'll use blue here. Notice that we have a 2 by 2 here. Oops, I want regular drawing. 2 by 2 and a 3 by 3. You can do 4 by 4s and others, but you're going to want to use some electronic means to do those. And you can actually do these on a graphing calculator as well. But we're going to do this here right now by hand because at least one of my problems on the test will require by hand, and others you can use the calculator for. If you are using the graphing calculator, once you enter a 2 by 2 or 3 by 3 matrix, there is a DET command in the part of the graphing calculator where the matrices are. So you can find that, and you can find the determinant that way. So first thing here, go back because I want to look at the 2 by 2s. And every 2 by 2 has 4 numbers, so A, B, C, D. And if you multiply the AD and subtract the B times C, multiply those out, then you are able to get essentially what the single number is. So let's do that. 6 times 5 minus negative 8 and 3, or 3 first and then negative 8. 6 times 5 is 30, and minus makes it plus 24, and that's a total of 54, and that single number is the determinant for that matrix. Okay. Notice too that these are straight lines. They are not the lines for matrices. So when you see those lines without, let's take that away now. When you see just the straight lines, it's like that's an instruction to you to do a determinant. Now that you know how to do a 2 by 2, or a reminder, because many of you have seen this already, you can use that, we call it expansion by minors, in order to do a 3 by 3. So look at the pattern here. We're going to use these top ones, A, B, and C, as multipliers, A and B and C. The B we will also do as a negative of whatever it is. And then we're going to do a pattern here. So notice first, I'll go back on here, this one for A, here is A, and it's going to multiply to these 4. Notice they are not horizontally connected to A or vertically connected to A. That's the key for remembering which ones to use. And then when we do the B, I'll take those away so you can look at the B. The B is going to use DG and FI. And notice those are not connected horizontally or vertically. That means you can figure out what the C would be, because here is the C. There's the C, and we have one right here that are not connected horizontally or vertically. We're going to follow that pattern for this one here. So let's call this one A, that one B. Oops, that's not a very good B. That one B, and that one C. And I'll switch to the blue. I just like that one better here. Okay, so here we're going to do the 3 from here, and then we're going to do the 4, 5, 1, negative 3, minus the B, negative 2. And the ones that don't touch that are 0, negative 1, 1, and negative 3. And you have to get the order of them right. So like these two are going to be your left ones, and these will be your right ones, just like they are on here. So make sure you follow that order. Then we're going to have plus, C happens to be a negative, okay, so we'll plus that negative. And then the ones for that will be 0, negative 1, 4, and 5. Whoops, not parentheses, but rather the determinant. Right? So what we'll do here is 3 times 4 times negative 3, and I have to do this big one, minus 5 times 1, okay. So 4 times negative 3 is negative 12 minus 5. That is negative 17. Let's come up a little bit. So we have 3 times negative 17. Over on this one, we're going to have a plus 2. And we're going to have, 0 times negative 3 is 0. minus negative 1 times 1 is a negative 1, so that's going to become a plus 1. Okay, so this is going to be 2 times 1, that's going to be a plus 2. So we don't have as much to multiply as we do here. On this one, we'll have negative 2 times, 0 times 5, so that's just a 0 there. That's nice. And then minus, negative 4 times negative 1 is negative 4, but it's going to be plus 4. So that's going to make this a negative 8. So let's multiply this 3 times negative 15, that's negative 51, plus 2 minus 8. And that equals negative 57. That's the answer for the determinant of this particular 3 by 3. There's another method. This appeals to some people, and so let's go through how to do it. We are going to make diagonals. Okay? For the diagonals, we're going to use a diagonal of these 3 numbers, these 3 numbers, and these 3 numbers. But wait a minute, there's no numbers there. Well, you're going to add them. The first step to doing this, and now I will switch to black on this, is you repeat the first 2 columns, 3, 0, negative 1, negative 2, 4, and 5, so this column and this column. You don't care about this line that's here, that just doesn't matter in the diagonals for it. So what I'm going to do now is I'm going to look at these 3, and these 3, and these 3. So I am going to figure out what those are when I multiply them. And go back to the black here. So that's basically 3 times 4 times negative 3, okay, plus the next ones, which is negative 2, 1, negative 1, plus, negative 2 times 0 times 5. The 0 is there, so it's just 0. I don't even have to think about that one. So this is negative 36, and this one is positive 2. Negative makes it positive. So this is negative 34, but we're not done. That's for half of it. Because once we do that half, or we can set this up earlier, we have to subtract the same thing over, but this time the diagonals will go this way. So let's do that. Let's set up, and I'll repeat the entire same thing. Negative 2, 4, 5. Negative 2, 1, negative 3, and then I will simply repeat 3, 0, negative 1. I don't need the determinant line for that. I can just write those down now. So we repeat the entire thing, and then we do the diagonals for that. But this time, look at what happens. The diagonals, because it has to be 3, so we have to use that 3, and then that 3, and then this 3. All right, let's do those numbers. Negative 1, 4, and negative 2, plus 5, 1, 3, and that 0, this one here, we don't have to worry about. That'll just be plus 0. It doesn't matter. So that's negative 1, 4, negative 2. That's what? 2 times 4. Positive 2 times 4. It looks like that's an 8. And this one here is 5 times 3 is 15. So 5 times 1 times 3 is 15. That's a 23, but it's minus. So it's negative 34, take away 23, which is negative 57. And that's the same thing that we just had above. Whoa, that is not coming out very nicely. Maybe I'm too close to the edge. Negative 57. So negative 34 minus 23 gives me the same answer as doing it by the other way. So there is a lot of work to have to break these up and then do the multiplyings of them and add them. But there's also a lot of work on this one, rewriting it and having the diagonals go in a different direction. Either way works. You can be correct, just be very precise and be careful. And you can get the determinant of a 3 by 3. You can also do this in the calculator, because if you enter this as a matrix in the calculator and then use that DET key or command, then it will give you this number exactly. It will go right to it for you. So there are times you might want to do that if you're allowed to. Now, let's look at how we're going to use them. Okay. This person named Kramer came up with a way of solving a set of equations like that. You've learned already how to do that, but you can also do it here this way with these matrices, a 3 by 3, and it's actually, this is an augmented matrix, the one where you also include the answers. So we have the x's, 1, 2, and negative 1, 1, 2, and negative 1 here. And then we have the y's, negative 1, 3, and negative 1. Those are in the y column. And then the z's, and then we have the answers here over on that. Okay, I'm going to take off those extra things. Didn't need to really write them, just to point things out. So notice what we do is first find, and we'll do it, look at the pattern that's here. This D1 is not including these. So it just has the coefficients of the x, y's, and z's. Okay, so that's important to see there. Let me take that off now. Okay. This one that's d of x, now this is important to see. The ending part here, that's the answers, those are replacing the ones that are x's, because those are the x's, those are the y's, those are the z's. We're going to use that, but we're going to remove the x's and place the answer numbers instead. And for the one that's a y, I'll put this in a different color. I haven't used the green here in a while. So the y one, it's the middle ones, the y's here. Those are the ones that now get replaced. And for the z's, you've got an idea now what that'll be. For the z's, we're going to replace, as you see here now, the z's. So we keep the x and y's and replace the z's. So we now have 4 determinants. We have the basic one for this. I should switch to another color. I'll go back to black for this one. So we have that one that doesn't have the answers in it, and the others where the answer numbers replace the x, y's, or z's. So you can do either any method to figure out what the determinant is, but I already did here. 19, negative 38, 57, and 76. So that's why we did this, so you can figure this out either by doing minors or by doing diagonals or using the calculator. And once you have them, now where we're at, now where we're at here is, what do we do with it? Well, if you want to know what the x is, you take the one that's the determinant for just the x's and you put it over the main determinant, negative 38 divided by 19. I got those numbers from here and here. Okay. And that gives me negative 2. And then, I'll try this one. This one here, oh no, I'll go back to the green now. For the 3, we're using the 57 over the 19. And you can see what comes next. Then the Z1 uses the 76 over the 19, and we get 4. But don't answer it this way. You have to answer it as a coordinate point because it's where 3 planes are meeting. So what you have seen here is how to do a 2 by 2 matrix, a 3 by 3 matrix either by minors or using the calculator. That I didn't show here, but you'll be able to figure that out or ask for help on it, or diagonals. And you can use a bunch of 3 by 3 matrices to solve a series or a system of 3 equations with 3 variables. There are some practice ones you could now do. Go ahead and do that. And I recommend to work on it yourself. Stop the video, come back in a few moments, and I'll have the answers posted. But go ahead and do it yourself now. Okay, now that you are back, I will write the answers up here. Okay, so this one we would do 9 times negative 3 minus negative 7 times 4, which is negative 27 plus 28. That equals 1. On this one, you can do it either which way. I'm going to do it, I'm just going to tell you the answer here. It's negative 24. Okay, and this one now, If you solve just for the z's, then you have to be careful of the matrices. I will write up the matrices here. The D matrix does include the coefficients of the z's. So the D matrix will be 2, 3, 5, 3, 2, 7, 7, -5, and -3. And the one for just the z will have the x's just fine, the y's just fine, but it's going to use these now to replace the z's, 13, -22, -28. And when you calculate the 3 by 3, especially if you're going to do it a bunch of times, do it on the calculator, and it will tell you that this is 87 and that this is 261. So we will do dz over d, 261 over 87, which is 3. So the answer to solve for z, we would say, if it's just being said for z, we would say z equals 3, and we are happy. We know how to solve a system of equations for any of the variables. Okay? I hope that helps to see these and understand how to do them. Thank you for watching, and keep working on practicing those and doing well with them. Goodbye.